So, today we are going to start by talking about the basic concepts of Git, and that follows the basic commands yesterday, but now we are going to go into a little bit more detail. This is not meant that you need to in any way memorize any low-level details or commands here. The goal is to learn more about the basic concepts. The hash sums, blobs, trees, commits, references, branches, because understanding these concepts will help you understand what the commands do and hopefully help you to easier solve conflicts and such when they appear. So this will build on what Pedro talked about yesterday and hopefully be a basis for some of what Diana will talk about afterwards about commit trees. And I just want to repeat what is Git. Git is a distributed version control system. It doesn't rely on a server client model. Instead, everyone has a copy of the entire project, the repository locally, with a complete history, metadata, etc. So you can work on it independently, even if you are working together with someone. But you usually will have a server to distribute changes if you're going to work with someone. So why would you use Git? It's popular. Many projects already use it. People know how to use it. People can tell you how to use it. By that I mean, if you are Googling something, there will be a lot of hits usually, especially from Stack Exchange, but also other places. And that is definitely an advantage. If something slightly weird is happening to your repository, there will probably be someone else who has experienced it and can say something. Git relies on hash sums and has built-in data corruption detection and built-in security. It's distributed. It's fast, simple, and flexible, as well as free and open source. So these are all good things. It can also sometimes be behaving a little bit weirdly, and hopefully this will help you understand some of what goes on behind the surface of Git. So how does Git store the history? What is inside of a repository? And I am going to go ahead and actually create a repository here. I'm inside this directory that I created yesterday. So I'm just going to create a repository. This command here just says that you create the repository and you also give the command to change to the repository. So it's the same as saying mkd a repository and then cd repository. So now I'm inside this directory. It's just a regular directory. And there I'm going to write git init. So I will initialize a repository, an empty repository. And it does so. It also gives this text here again. Just ignore it. It's just something that depends on probably the version of Git you have. It's telling you that the master branch is called master. In some cases, it could be called main. It will be on GitHub. If you prefer it, you can set what you want the default branch to be called, and you can also rename it. It's something you might have to deal with when we go into GitHub, because you need the main branch or the master branch to actually have the same name there. But for now, it doesn't matter. And my Git is using master as the name. So this is how it looks inside of this new empty repository. I will try and type find, and it actually shows everything that is under this repository here. So there's the repository, there's .git, which is, as you can see here, it's a hidden file, but if you type ls-la, you get the .git, and inside of .git is the repository files, and there are any branches will be there, hooks, info, objects, refs, config, description, and head. And we will now look a little bit into the various subdirectories and see what they do. Most directories are empty. The files that are there are not interesting. We could look at the config file as we do here. So I will say cat git config, and it really doesn't have much there already. It's just a very basic setup for repository. Then we have the head, and it tells us it points to the head of the master branch. And it also tells us this repository does not have a name. I could edit the file description to name it if I want to. I don't care about that right now. So let's go ahead and add some content and see what happens. This line here, first I'm going to repeat, ignore this $sign here, the first, because that's just a representative of the prompt. So echo repeats to the screen what it is you are saying inside of quotes here, and that is then redirected into the file.txt. So let's go ahead and just copy this here. And now we will have a file called file.txt. I'm going to add it to Git as we saw yesterday with the command git add file.txt. And then I'm going to commit it, stage it, as Pedro talked about yesterday. This is the first commit. And it adds it here. And it also tells us something, namely this create mode here, and it tells us something else. It gives us the first part of the hash. And I should have that somewhere, minus here. It will be different a little bit depending on what you write, this is probably because I also have more stuff here. In any case, this is a repository. This is a file, so that was changed. This is the file tree, it now has file in it. And let's see what goes on under .git. There has been changes done into the logs. There is now a commit message. There's changes in the index. Nothing has happened to branches. We didn't create branches. Nothing in hooks. Objects. Now stuff has happened here. We have actually 3 things happening under the objects here, and we're going to look at what those are. And we also have one more thing here. We have head is pointing to master. Nothing else has happened. Everything inside repository is part of what we call the working tree or the workspace. .git is not included in the working tree. It's this part over here that is the working tree. And it contains just the one file, file.txt, and working tree is just a regular directory. The git add and git commit commands tell Git that it should now care about the file.txt, so it's following it now. And that means it will know about changes to it. Objects. Git stores files, etc. as objects. They are stored under .git objects here. And if you look here again, you see this hash here. You recognize that this is the first part of this here. So that might be a hint of something happening. Git uses content-based addressing. A hash sum is computed from the content of the object. The hash uniquely identifies the object. Two objects which has identical content have the same hash and are stored only once. We can actually compute the hash manually. So let's try and do that for this file here. And you see here, it's this long thing here that is the hash object. And that is the same because it's the same file, it has the same content. So we can find the corresponding object. If we do find, then it should be here on the objects. You see this one here. 09 here. That is one thing to note. The first part of the hash is a directory with the rest of the hash under. So when you are looking for it, you look for a subdirectory that is the first 2 digits of the hash, and then under it will be the rest. It's here. So it's there, as we expected. And we can also confirm that 2 files with identical contents have the same hash. So I'm going to go ahead and do this. I'm going to copy file text to file to text. Those two should be identical. I forgot an H. And as you can see, they indeed are identical, and they also have identical hashes. So that's good. As you probably guessed, you do not have to use the entire hash. As you saw previously, it only showed part of it. And you can do that here also. You can copy parts of it because you usually, unless it's a huge project, you will not have enough similar files that you have to go all the way and include the entire hash. It will probably be enough to just take maybe 7, 8 characters from it. And if it's a huge project, maybe 12. But let's try do this. Git cat file -p. And then we will copy the first part of it here. And then we see it finds it. This file is very interesting. And in this case, there are only 2 files. They are identical. It's easy for it to find it. So here we could use even fewer. It would still find it. And it will do the same thing if you included the full one, as you can see. If there are many files that are similar, if there are some that has a hash that starts with the same few characters, Git will give you an error message, and then you just include more characters of the hash in order to find what you're looking for. Objects cannot and should not be accessed directly. You can look what is inside it with hex dump, and it just looks like this. I mean, we're not going to look at it directly. There's no reason to it, but we can do this just for the fun of it and see that it does the same thing. Hex dump just dumps out the content of a hex file, a file in a hex format instead of binary format. But what we can do is we can observe the type and the content of an object. And we do that with -t to cat file and -p for the content. So let's try and copy this here. And we are told that the type is blob. That is what Git uses for files. And let's see what content is. Well, that's the content that was in the file. This file is very interesting. It's also important to realize the object stays even when the file is removed. So I could remove my file here now. And I could do find. And then go up here and see that it's still there. Now, why is this? Well, I actually didn't commit this either. I just removed it. It's removed from the file tree. It's not removed from Git. So let's see what we get when we do this. It finds it. It tells us what's in it. And we can restore it because it's still in Git. So this shows you that even if you delete your tree from the file tree, even if you delete your file from the file tree, it's not gone if you have actually committed it to Git or staged it to Git. So I will restore file.txt. And then I can see it's now again here in my directory and all is well. Let's look at the repository again. Now we know this here, this hash here with a blob, this is a file. The content of it. What are the other two objects? These two. Let's take a look at them. And let's see what they are called here. I'm going to do find. And I have one here, 1A, as you can see here. It's the same. So I'm going to do git cat file -t. And it tells me this is a tree. And let's see what the content is. The content is that it has pointers to the file, the blobs, and to other trees. And trees are used to represent the directory structures. So this was a tree, this one. And the tree has one level and it has one blob. So there's the tree with this hash. Yes. There, this hash. And the blob, which is a file, which was the one that had this hash. And inside of it, the content of the blob is this file is very interesting. Again, let's go back and look at the repository because there's still one object that we have not looked at. What's inside of it? And in mine, it's like this. I'm going to look at it. Git cat file -t. And I am going to remove this slash. And then I'm told it's a commit. Now you noticed there are differences between my commit here and the commit that was here. That is because a former colleague of mine made this example and he used his name in it, of course, at the time when he made it. So because of that, it looks differently. I put my name will have gone into it when I set the git config. So this one of it is different. The others are the same because it's the same tree, the same file, and the same content. The only difference is in the commit file. And you will see the same when you do this example. Those two will be the same. This will be different. So this was a commit. And let's see what it says when we look at the content in it. And as you can see here, it's a tree that has this hash, as we found before, this hash here. And then we have the author, which is me. And I also committed the file. And then the content, which is the commit message, this is the first commit. So the type of the object is commit. It contains a pointer to a tree here. It contains an author and a committer plus the time, and it contains a commit message. A commit stores the state of the project in a given point of time. And in this case, the commit points to a tree that has one level and one blob. So, as we have here, tree and the Git content. More generally, the associated tree can have several levels and multiple blobs, of course, because you can have many commits and you can have many files inside of it. So you had your tree here with various directories under it and files under it. And then there is the content in .git, which is the commit messages and the blobs, the files, and the trees, the directories under it. Okay, so we are working with Git. Let's see more of what we can find inside of .git. We have now looked at this here, the objects. But what about the pointers or refs? They are here, and that is what we're going to look at now. And head and other references. Head is the more important one, and it will point indirectly to this commit. So if I do cat here on it, it tells me it points to the head of the branch master, the only one. And then let's see what that is. This ref's head master. That is indeed pointing to this commit message we had here. It's pointing to that commit message, to this one over here in this tree, and in mine, that is what is here. So head points to master, the tip of the branch, which points to the newest commit, which points to the tree, which points to the file, the blob. So head and master are references. A reference points to commits and another reference. Head determines the most recent commit. And many of the commands in Git you will find act on the current head. And we will talk more about that later. Master is a current branch, and we will also talk about that later when we come to branches. You can create references yourself with the git tag command. And you may have situations where you want to use that. But you can see here, you then get a tag, and you will then have this one here, and it will point to the same. We can try and create one. And then do find, and let's see if we can find it here. It should be somewhere. Git refs tags first. It's here. And if we do git rev pass first, you will see that it finds the commit, this commit here. It's pointing to that just as head does. And I'll show you here. this one here. That is the first commit that we're pointing to. So it's pointing to that also. So it simply points to the same thing as the tip of the master branch as head does. So let's try and add some more stuff to it and see what goes on. I will now throw more content into file.txt. And nothing happened here. I can cat the file.txt. It now has the line more content as well. I will add it to Git. And after doing that, there should be a new object here. See if we can find it. It's here. So it's here. And we can then do git cat file -p, and then the one we copied here, but I need to remove the slash. And I can also just take a few of the characters to show you that it finds the file. It finds the commit, sorry. The git add command that created a blob corresponding to the update on file.txt, but no other objects are created yet. The command also adds the file to the index, and the index will become the next commit when I do git commit. So that represents, that is a representation of the tree object. And the index is a binary file. And now I will take this index, which should be somewhere there. And I will create a commit where I say this is the second commit. And we now have the first part of this hash for the commit message. And as you can see, again, this would be changed compared to what it is here because I have a different name and a different commit message thus. As before, we have a tree object describing the directory structure. So let's do git cat file -p, and then we are grabbing the first part of the commit, and then you can see what was in it here. I was going to say T, I guess. So there's a commit. And the tree is this one here. We can see what we get when we grab that. Here we see that it points to this blob, which is the file.txt. And we already did this. This was the commit that we looked at here. So the major difference is that the commit now has a pointer to a parent. And that is what you see here. Because now there is not just one commit message, but there's also a previous commit message. And the commit message points to the previous message. So this is the parent pointer. So this is the newest commit, and it points back to the previous commit, which, as before, points to the tree and the blob. And this is what is in the file tree. The tree and the file with its content under it. Usually we would have a complete tree of commits, a commit tree. So as you can see, you would have several commits, each of them pointing backwards. If this is all you have done, just commit it, made a new change, committed it, and so on and so forth, it will look like this. and each commit represents the state of the repository at a given point of time. And each commit is allowed to have multiple parents, of course, because maybe you actually have several commits and you are going to make a new commit from those two. And that usually happens when you have branches that you now merge. And that is a common thing because maybe you are going to work on a feature in your project. Then you will create a new branch where you will work on this feature in, and then when you are happy with it, you will merge it into your previous branch. And that is a common way of working. And then you would get a commit that has two or more parents. That is something we will talk more about when we come to branches. So we will look a little bit again at head and the other references. Let's try and investigate the head and the master. So let's try and do cat on .git.head. Again, it's still pointing to the tip of the branch master. And I'm then going to look at that and see what that points to. And it points to this commit here. And that commit should be the second commit, and it is, as you can see here. We can try and do git cat file minus p on this here and see what we get. And we see it's the second commit. And if we do T on it, we see the type is commit. So the head pointer is indeed pointing to the tip of the master branch, that is to the newest commit. So this is the working tree. What is inside of it? The file with the content. The head points to master, points to the second commit, points to the first commit. Again, remember, git commands usually act on the current head. We can change the head to something else if we want to do this. That is, we can move the head pointer. And what we can do here, we can see here we see that this is the parent. So let's try and do git checkout. Git checkout means that we move to a specific hash in our specific commit. And I'm going to grab the hash of the parent. And that tells me now, I'm just going to make this a little bit larger here, that I am switching to this commit here. And then I am told you are in detached head format state. You can look around, make experimental changes, and you can commit them. And you can discard any commits you make in this state without impacting any branches by switching back to a branch. And it also tells you if you want to create a new branch from this commit to retain any commits you create, you can do so now or later by using -c with the switch command. And these are all things we will talk about later. And you can also turn off advice if you don't want to see this. I'm usually keeping it because it's a good reminder. But what is now is that we have moved head to point to the first commit. And if you made changes to it now, then you would, when you wanted to save them, you should make a new branch from here. But we're not looking at that now. We're only going to see how it looks here. So this is a way that you can move around in the tree and see what was the status of my project at this time. And a thing you can see here is if I do a cat of the file.txt now. At this point in time, it shows me what Git knows of the file at this time, which is this file is very interesting. That means it has not yet added this second line. So everything, including the file tree at this point, looks as it did at this time. So master, the branch, it's still pointing to the newest commit, but we have moved head pointer to look at the first commit. And we could now modify the working tree to create a new commit. So I now will make changes to file.txt, even though there actually exists changes to it. So I will do that. I will add some extra content to it. And then I will say, yeah, I don't remember if Pedro covered it yesterday, but I think he did. You can use -a to add a file directly when you also do the commit. And you can do -m and give the message, as I have shown here before, instead of going into the editor. So it's simply a shortcut that I often use because it's quicker to write. And it tells you, warns you, you are in detached head state, but it doesn't make the commit. And we can look at the commit just as we could before. We do git cat file -p and then our commit. And then it tells me that this is a tree, and it tells me the parent is indeed the first commit. And it's so you did a third commit on top of the first commit, bypassing the second commit. And I'm going to do T on it also to see, yes, the type is commit. So the parent points to the first commit here. But the commit tree now has two branches because you have head that is pointing to the third commit and to the file as it is at that time, and back to the first commit, which shows the file as it was there. But you also have the master branch. The master branch is pointing to the second commit, which points to the first commit. At that time, this is how the file looks. And what we can do now is that we can actually name this second branch. It can be done in several ways. I'm going to do it this way here. And I will see if it works. It did, because if it's an old version of Git, it may not work. You have to do it in a different way, but I believe it will work on all newer versions. We have now created a branch called second branch from this third commit here. And we are pointing to the head of the second branch. And that looks like this. This here, that is the head of the second branch. Let's try to find. And we can find the object here, which is what it points to. And that is this in this example here. but it will be different in your example, just like it's different in mine. So the second branch, the new branch we created, it's pointing just like head is pointing to the third commit. That is what we are looking at. And this is a file as it looks, and it points back to the history. The master is unchanged. It still points to the second commit and to the file as it was then. So we can merge the two branches, and I'm going to do that here, but not talk further of it, simply because that will be covered under branches. I just do this in order to show you what happens with the tree behind. So you will have to stand on the new branch, and then you merge it into your master branch or to the so now we are there, and let's try and do a merge, see what happens. And of course it fails because it has to, because the file has been changed and it has been changed in the same place, so it cannot just auto merge them, because how will it know which one of the lines you want? That means that now you're in a situation where you would have to make the changes yourself. And I'm going to use nano and open file.txt. And here it shows us how it looks. So it says the head is pointing here. Your second branch is pointing here. What do you want to keep? Please make the changes. And I will do that. And when I have made the file look as I want it to, I need to remove these markers here also. And I could fix the conflicts in any way. I mean, maybe I want to keep both, or maybe only one of them, or maybe something else. But in any case, I will remove this marker here, and then I will simply keep all the content and remove the markers. That might not have been what you wanted, and in that case, you just keep the line that you want. But I'm keeping it like this. I have now made a change to the file, so I have fixed this conflict that I had before. And then when the conflict has been fixed, I will now again continue the merge. So I will add file.txt, and then I will tell the merge that I actually now want it to continue. And I get a commit message. I don't need to add anything further to it, but it has as default put here a line that says what is going on. We are merging branch, second branch, that the conflict was with the file.txt. And then it tells you what it is you expect you are doing, and how you can avoid it if that's not what you wanted to do. And you can add another message here if you wanted to say I'm keeping both changes to the file. You don't need to write anything, but I'm doing that here. And if you put anything with a hashtag, as they have here, then it will be ignored. And if you remove these both lines here, then there will not be made a commit. And it's telling us we are on branch master. It's telling us which conflicts we have fixed. And it says you have indeed fixed all your conflicts, but you are still merging. Is that what you want to do? So it's saying we are making changes to file.txt. We are not changing file2.txt because it's not tracked in this version. Anyway, we are happy. We are now doing the merge. And it now tells us that we have this commit here, which is a new commit that was created as we did up here somewhere. Let's see if we can find it here. Commit 4. That was made from merging these two commits. So this is the situation we are now in. And the commit, this one here, it gives us a message that they had given here and the one I added as well. And then let's see what it says here. Git cat file -p. And then let's look at this hash. Indeed, it has two parents. So it looks the way we expected it to. And the new merge commit was created from the two parent commits. And here are the commit message. So that looks as it should. And there's a picture here representing it. It looks a bit more confusing this way because I'm also showing the file tree. But the working tree, the file.txt, let's see what's here. We have file.txt, which is in Git, and file2, which is also there, but which isn't tracked. We have master and head. They are both pointing to our very newest commit, to this one here. And it points back to both the third commit and the second commit. And each of those has the tree as it looked at that time. And they both point back to the first commit, which shows the tree as it was at that time. And I am going to we had been looking at how the working tree and Git looked after we have merged two branches. And now I will continue on from that. So switching to a specific commit. Well, we just saw how you did that. You can always move back to any of the previous commits. And you do that with the git checkout command. And if you do that, just like before, you can do git checkout and then go back to a previous commit. This, for instance. And then let's see where we are. And then we will go to the commit to the parent of this one. Also. So that is the other parent, this one here. And you can see now we are on the second commit. So we can move around in the tree as we did before. And we can use find to find the various objects here. And we can go back through them. Just like before. So this was the commit message that we had here after we merged the two branches. One of them was the third commit, the other was the second commit, the parents, and then the first commit. So this was just a very quick refresher of what we talked about just before the break. And now it is time to go to the exercises. And the exercises are over here on the side. Under exercises, there's one for basic concepts. So let's go to that. And the idea here in this one is that in the first you create a repository, stage, and commit a file just to see what happens. And then you take a look at the stuff under it. You try and make some changes to one or more files, then commit again and look again at the tree. And you can go to earlier commits and you can try and make a new branch if you want to. Remember git checkout to go to an earlier commit. And then when you have moved back to a previous commit, try and make a change there and try take a look at how everything looks there with git cat file minus p and then to find the hashes. And remember, you also have these commands here where you can see what the head is pointing to. And then also try and go back to the primary branch, which would probably be called master, might be called main. And there try and merge them. And there might be a conflict. And when you see the conflict, you will have to go into the file that had the conflict and then make any changes there so that it looks as you want to. And you also need to remove the git markers as I showed you. And you add the fixed file and then you continue the merge. And again, check out the commit tree. So we'll use these commands that we have looked at here in this chapter to try and do these exercises. And let's say get started on them. Otherwise, I have actually written a answer to them, but I will go through them here quickly. So since I already have a repository called repository, I'm going to create one called repo. So for the first one, I create repository repo and go into it. There's nothing in it. I'm going to initialize it, git init. I'm going to create a file.txt. I will just write something in it. Like this. Then I will add it. And I will commit it. And now I can take a look and see how it looks in it. So I'm already in my repository, so I don't need to change to it again. But I will do tree.git. And here you can see the objects and the branches and things like this. And it looks as we might expect. So I will try and do git cat file minus p. And then I could take a look at each of the hashes. Yeah, I need the double 2 zeros first. So this is the commit message. And if I do minus T, I can see it's a commit. And if I do the same thing to each of the two other ones, then I get to see what those are as well. So we have a blob, it's a file. And then there was one more, it was this one here. Let's just grab some of it like that. And that is the content of my file. And now I should be told that it's a blob. So the commit, the tree, and the blob. And then I will make some changes. Just make this a little bit smaller. So I change a file. I will try and create a file. And then I will also make a change to my first file. Like that. So now I made some changes. I will add it. And I will commit it. And I don't know if I said or if we talked about it yesterday, but if you say git add and then a dot, then you are adding all the files in the current directory and below it. So it's a powerful command, but also one to be careful with if you have something you don't want Git to track. So now we have made some changes and we have committed them. I'm going to make yet another change. Yes. And then we again adding it. And now let's look at the file tree. And now you can see there's a lot more objects. If we go up to what we had before, we had 3 objects. And that is this one, and this one. But now we have also added more because we have added 2 more files, and we have added new stuff to the file.txt. So I will try and say git log, and I can see I have 3 commits, and I can see what they are. I will also just do one check for what type of file it is. So let's try and maybe take this one here and see what that is. That is a tree. And it has 2 files. Now, here we saw with git log, we saw the commit messages. And I'm going to try and do a git checkout on one of the previous ones. And you can, if nothing else, see here which ones are the oldest ones. So head is pointing to this one here. So that is the newest. But you can also see the times of it. So I'm trying if I can go back to this commit here. So now I move back in time to my previous commit, to the commit just before this one. And I can try and see git log. And as you can see, head is now pointing here, and we have the previous commit. I'm now going to create a branch here, but first I will make changes. I will make changes to file. And as you can see, file has only the 3 lines I had added at this point. So different line here. And then you will see that when I try to merge them later, I will get a conflict. I will also create a file more. Yet another file. And let's see what we have. We have 3 files here at this point here, because the other one was created at a later point. So I will add it. And commit it. Like this. And now when I have added and committed it, I'm going to create a new branch. So I will do git checkout -b, and I'm not inventive, so I'm calling it second branch again. And let's now see what the hash is that the head is pointing to. So we will look at git head. It's pointing to second branch as we expected. So we will look at this here. Refs heads second branch. What did I do wrong? Such file or directory. That's because it's under git. Like this here. And this is the commit. So now that it's pointing to. So I'm actually now going to go back to the primary branch. Git checkout master. And now switching to master. And having switched to master, I would like to try and merge these, but let's first see what we are pointing at here. So let's do git head. And now we are pointing to master instead of second branch. So that is good. And I'm going to try and merge with git merge second branch. Let's see. What did I make a mistake here? Or did I forget to push something? Didn't I go to master? Yes, I did. Then I should be able to merge. What happens if I just say this? Then I'm actually getting the conflict. So somehow I wasn't on the master, but now I am. And I'm merging in second branch. And I'm getting a conflict as expected because I made change in file.txt in both of the branches. So in order to fix this, I need to open file.txt. And again, I need to make a choice here. And again, I'm going to make the choice to just keep everything and remove the markers. I could remove one of the lines if I just wanted to keep one of them, for instance. But now I have removed the markers, and I have made a decision on what I want to keep in my file. So now I'm saving it. And then I am going to add it, file the text. And now when I have done that, I can do a git merge continue. And here again, we have the merge happening inside of the merge. And I'm just going to go ahead and use this command there. And now it merged it. And now we can look at what the head is pointing to. It's now pointing to master, as it should. And we have with git log, you can see there's the master that head is pointing to. There's second branch, and then there are two other older commits that those are pointing to, and then there's the first commit. So it's all good. Okay, I am going to stop here and